Alrighty, open or just look at that first page of your packet. Looks just like this. You spent almost all of your 9th grade year in Algebra 1 learning about linear lines. So y equals mx plus b should sound familiar, yes?
Yes.
That is straight lines. Algebra 1 is almost entirely all about straight lines, solving equations, and simplifying expressions. In Algebra 2, we focus not on straight lines, but on lines with curve. It's kind of like the next step up. As graphs get more curves and bends, our equations get more and more complex. So the next step up from a linear line, which has an x with no exponents, is quadratics, which is what this whole packet is on. We're spending the next 2 weeks on it, and the rest of the entire quarter on solely quadratics. What makes a quadratic is it has an exponent of 2. That's what makes it a quadratic. When something has an exponent, we call it a degree, but no, quadratics have an x squared. Any function with an x to the power of 2 is going to have the same shape and all of these things we talk about. Okay? So, here are 2 examples of quadratic. One is pointing up like a smiley face. One is pointing down like a frowny face. The shape of a quadratic has a very special name. I would write this. That is our fancy schmancy name for quadratics. Anyone want to try and say it? It is a parabola. Not a parabola. That sounds like the next virus I wouldn't want to catch. Yeah, no one wants to catch the parabola.
Stop predicting the future.
Parabola. The parabola is a word that describes the shape. This shape is called a parabola. The equation is called a quadratic. Okay? So if you hear me say quadratic and parabola, they're interchangeable, but I'm just talking about the graph. So there are 3 things that are super important that we leave today knowing what they are and where they are and how to find them. The first one, most important part on every quadratic is the vertex. Every single quadratic has exactly one vertex. This vertex is either at the tippity top or the very bottom. Either at the tippity top or the very bottom. Our first example, it has one at the very, very bottom. You can see it right here. Our second one has a vertex at the tippity top. It's that point that's way on the top or way on the bottom. Most important point out of any point on this parabola. We need to be able to find that. So, it is a point. It is not a single number. For example, this vertex is at the point -1, -4. That's the vertex. Our other one is -1, +4. That's the vertex. The vertex is right in the middle. See how it's perfectly in the middle of our quadratic? And it's at either the highest or lowest point. So make sure you know where the vertex is. Do we feel like if I drew quadratics, you could circle the vertex? You know where to find it? You know where it is? Yeah? Okay, vertex. The next, x-intercepts. X-intercepts. You've heard this word in Algebra 1. It's where our graph, our parabola, will cross the x-axis. So if I highlight the x-axis right here, our x-intercepts are wherever our quadratic run into that x-axis. So we have one here, second one here, one here, second one here. Now, it is possible that you have none, you could have only one, or you can have 2. Okay? What's most important is you understand that x-intercepts have a lot of different names. We call them x-intercepts. We can call them roots. We can call them solutions. We can even call them zeros. Okay? We're not going to be finding x-intercepts today, but you do need to know where they are. Again, it's all about could you look at a graph and find them. Okay? Last but but not least, axis of symmetry. You guys know what symmetry is, right? Something that's symmetrical means it's the same on both sides. Parabolas, quadratics are symmetrical. If you draw a line right down the center of your graph and it goes through the vertex, the left side and the right side are exactly the same, always, every time. If you took scissors and cut a quadratic right through the vertex, both sides would be identical. They're symmetrical. Okay, those are our big things. So this next 2 weeks, there are 3 ways to write quadratics, and we're going to spend time on each way. In Algebra 1, that y equals mx plus b, that's one way to write a linear line. You can also do standard form for linear lines. In quadratic, there are 3 ways: vertex form, intercept form, and standard form. Today, we're just doing vertex form. Okay? So, flip the page. Should see one that looks like this. Just like this. Up at the top, this is vertex form. It's one way to write a quadratic equation. Now, I will never have you memorize this. You do not need to have that memorized. So don't sit there like, oh my gosh, I have to memorize all 3 ways. No. This is what it looks like. You don't have to be able to write it down by memory, but what you do need to be able to do is if you ever see an equation like example 1, you should be able to look at it and know that that is vertex form. So there's going to be 3 forms, and they do all look very different. For vertex form, there will always be parentheses with an exponent of 2. So I would give yourself a little note here. Whenever you see those parentheses with an exponent touching it, and that exponent is 2, that's vertex form. When I look up here, I go, oh, parentheses, there's my exponent of 2, that's vertex form. Easy peasy. Okay? So vertex form, just be able to identify it. You don't have to be able to spit out that actual form. Just be able to tell what is which. Vertex form. Vertex form has 3 very important parts. It has an A value, an H value, and a K value. And now that, right now, means nothing to you. But these 3 letters, the A, the H, and the K, let us figure everything we could possibly want to know about this quadratic. So the first thing we need to do is be able to identify them so that we can use them and make our life really easy. It's way easier to work with 3 separate numbers than have to try to figure out what an entire equation is. So based on my vertex form and my first example, what is my A value? 2. Here's A. Oh, wrong color. Here's A right here, which means my A value is 2. So we know my A is 2. Okay, so that's first step. Identify the A value. Now the H value has a slight little trick. The H value. In order to identify the H value, we just need to make sure we flip the sign. And that's because in vertex form, there's already a minus there. So if we said that H value was 1, when you plug 1 into vertex form, it would be x minus 1. But we want it to be x plus 1, so we just need to remember to flip the sign. So our H value is not positive 1. It would be negative 1. Just flip that sign. Positive to negative, negative to positive.
Do the same thing for K and L.
K, we do not do that. H is the only weird one. A and K, you just write like it is. So this is our K, and that is just negative 3. Just like how it looks. So H is the only weird one. If you would like, I like to put a box around here just so I know hey, that's the weird one. A and K are the same. H, flip the sign, don't forget. Once we have A, H, and K, which we do, now we can pretty much speed fill out the rest of this. Step 2, we're finding our most important point, the vertex. The vertex is always at the point HK. That means whatever H is and K is, that's my point. So we know H is -1 and K is -3, which means my vertex is at the point -1, -3. Which makes sense. That was pretty easy to find the vertex, wasn't it? Which makes sense because what is this form called? The vertex form. It's called that because when you just look at the numbers that make it up, you can tell what the vertex is. So H was -1, K was -3. That's our vertex. -1, -3. So if we went to our graph and we went to the left 1 and down 3 and plotted our point, that would be either the tippity top or the bottom of the quadratic, right in the middle. The axis of symmetry is our third step. And again, what's important about the axis of symmetry is it cuts the vertex right in half. It goes right through the vertex. That means our axis of symmetry is either going to be -1 or -3. But our axis of symmetry goes down through the x-axis. So our axis of symmetry is always going to be x equals, because it's a line, the x value, which is -1. So every time you see vertex form, you write down your A, H, and K. Don't forget to flip H. Whatever H and K are, make up your vertex. And whatever the x value is, that's your axis of symmetry. Every time you see vertex form, it's boom, 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 done. So we've used H and K to find our vertex and axis of symmetry. Now we need to use the A value to figure out if this is a maximum, meaning it looks like a frown, or it's a minimum and looks like a smile. And all you have to do is look at your A value and figure out if it's positive or negative. In this case, our A value is it's positive. When the A value is positive, there's a minimum. So how do I remember this? Well, if you're having a positive day, you usually have a smile on your face, don't you? You're having a good day, you're feeling positive, you're smiling. And smiley faces have a vertex that's down at the bottom, a min. If your A value is negative, we say you're having, negative day, it's a bad day, you have a frown. You're sad. Frowny faces have a point up at the tippity top of the frown, and that's your max. So if you're feeling positive, smiley face, min. If you're feeling negative, frowny face, max. So this is A is positive, so it has a minimum. How are we doing so far? Not too bad, not too shabby. Now that we have our vertex axis of symmetry and we know it's going to have a minimum, now it is important that we can graph this. And back in the day, you used to have to find all your points by hand, plug in 1,000 numbers, but we're going to use our calculator, which only requires us to hit a few buttons so that we can plot it. So first things first, we know one point of our graph, we know the vertex. So we want to make sure we put the vertex in the middle of our table. Why would we want it in the middle? Because where is the vertex? Right in the middle of the graph. So we're going to write our vertex -1, -3 into our table. -1, -3. So vertex in the middle of your table. It's the center of our graph. We want to put it in the center of our table so we can get our points on our left and our right and get the complete picture. So the question is, how will we ever find the rest of these x values? Well, and y values. Our calculator is going to do that for us. So for x values, what's nice is we can fill it in because if we're counting down, we'd go -2, -3, then getting bigger, 0, 1. Does that make sense, getting those x values? Okay, we can fill out the x values. We know where the vertex is. We want to go down and up, but we can't find these y values unless we sit here and plug everything in. But we're going to use our calculators to help us find our table. So calculators on. Calculators on. First thing we need to do once our calculators are on, and remember, I know how to plug this in, I promise you. You are learning right now, and it is important you push the buttons. It'll help you remember. So, first things first, we have to type in our equation. And all equations start with y equals and then our function. So we're going to look at the top left of our calculator and click that y equals button. And you'll see a bunch of lines where we can type in a bunch of equations, but we're only going to worry about typing it into the first one. What's up? Question. Good?
My calculator not working.
What's that? Okay.
So you click your y equals, and let's start plugging in our equation. I have it right here in this little box, what it should look like when you plug it in. Or you can look at the top of the page and plug it in. But make sure it's exactly 2 parentheses. Super important. I don't think we've had to plug in an X yet this year. The X button is right next to the green alpha button. It has a blue word link above it, and you should see it has an X, a T, a theta. That button next to alpha, when you tap it, that gives you your X. Okay, X plus 1. Do we get the X? Second power. -3. Huh? Yeah, we'll do it again. I'll clear it out. Okay, so we type in 2 parentheses. X plus 1. The button for X, the variable button, is right next to the green alpha button. It has an X, T, theta, and an N on it. Click that, there's your X. Plus 1, your exponent. For quadratics, we need second power. It's right above the button that says log. See that X squared? And then -3. Yep. -3 at the end. Once we have that in, now we need to turn this into its table. We want to know what the table is so we can plot its points. So a couple buttons over is a gray button that says graph, but in blue above it, see how it says table in blue? So like our directions say, second graph. Second graph. And up should pop our quadratics table. Okay? What you want to do is go find the vertex. You might have to go up and down to find it. So use these up and down buttons to find the point -1, -3. That is our vertex. And above it and below it, we have our points we need to add to the table. Yes, but we want to go to our vertex, which is -1, -3. So you're going to have to go up to negative. There it is. Now we can add those value points into our table. Now we can put a square button. What do you mean? Second graph. I mean, it's up on the board. That's not our second graph. There's our table. And then you find -1, that's our vertex. And then we graph.
Oh, I got to do that too.
Oh, you have to do second first. Yeah. And now find the point -1, -3 on there. You can click up and down on that little reference pad. Yeah. All right, click your Y equals. X button
We ever plug it in?
Right.
and then you
If you're not gonna use it, you can't keep it, right?
So you just see it says and Okay, so hopefully we have our table. You find your vertex, which is here in -1, -3, and now I can fill in the rest of my table. Up there it tells me there's -1s right here, and then +5s. Okay, so my calculator helped me finish out my table, and you'll notice, look at the y values above and below the vertex. See how they match up? See how they match up above and below? -1, -1, 5, 5. In my calculator, it goes 15, 15, 29, 29. That's because a quadratic is symmetrical. Shh. All right, we're going to plot, and we're done with this example. Okay, so I'm going to plot my vertex first. -1, -3. Left 1, down 3. There's my vertex. There's my vertex. Okay. Shh. Now I'm going to plot the rest. I'm going to go up first. -2, -1. -2, -1. -3, up 5. And I'm going to do the same on the other side. 0, -1. And you should start to notice, over 1, up 5, that my graph is symmetrical. The points on the left and the right side match up. I can connect my dots. There's my quadratic. If I were to take scissors and cut down the middle through my vertex, that would be your axis of symmetry. Your left and right side should look exactly the same. Every time we do vertex form, these same steps will work, no matter what.